So, welcome back. Part 3 of Chapter 7. We're going to turn away from condensation and dew points towards a notion of stability and cloud formation. Stability is a term that you will hear frequently on the evening newscast when they talk about rainy weather in particular. The best way to think about it perhaps as a hot air balloon. First of all, think of air in parcels, almost as if the air is contained inside a balloon. And when a parcel of air, like a balloon, is heated, it rises using something called the buoyancy force. Essentially, the air molecules spread out, they become less dense than the surrounding air, and then they are able to rise because they are less dense than the surrounding air. On the other hand, when the air inside a balloon or a parcel of air cools, the air parcels, they get closer to each other, become more dense, and with more density, they weigh more, so to speak, and the air balloon or the parcel of air decreases. Instability essentially happens when there are parcels of air that are rising. So here's the terminology. Stable air is when a parcel of air neither moves up nor down, or if it is disturbed, it tends to return to its starting place. Unstable air continues to rise until it reaches an altitude where the surrounding air has a density and temperature that is similar to its own. How stable air is depends on the temperature difference between the air parcel itself and the surrounding parcel of air. Keep in mind, the normal lapse rate, a term that was introduced earlier, is what we use to characterize the average decrease in air temperature for air that is still, not moving, not circulating. It's about 6.5 degrees Celsius per 1,000 meters rise, or in Fahrenheit, 3.5 degrees per every 1,000 feet that you would go up in altitude. The environmental lapse rate is different, but only by degrees. It's the actual change in air temperature with change in altitude, whereas this one is the average, what is normally the case. It's not always the case, and in fact very often is slightly different than the normal lapse rate. So the environmental lapse rate is what is currently outside, and it may or may not match the normal lapse rate. A couple of terms here, adiabatic and diabatic. Normally, air cools as it rises because it expands and air pressure drops. Air heats up as it descends because it is compressed, and compressed air, the molecules touch each other more and it feels hotter. The word adiabatic means occurring without a loss or gain in heat, and then diabatic means there is an exchange of heat between the parcel of air and the surrounding area. So we are going to talk a lot about adiabatic lapse rates, meaning adiabatic cooling. In adiabatic ascending, when air parcel rises, it expands and the temperature inside the parcel decreases. And so this is sort of what we were just talking about. As it rises, air expands, the molecules are separated from each other, it becomes colder as a result of this expansion. Descending is just the opposite. When air lowers or comes down through the atmosphere, it heats as the parcel of air, the molecules inside the parcel of air is compressed, and those molecules are touching each other and thermometers far more often. There is a rate at which this happens that is predictable. It's called the dry adiabatic rate. It's the rate at which dry air cools by expansion when it's going up, or heats as it's coming down. Dry air is the kind of air that is less than saturated, so it hasn't reached the dew point yet. Humidity is less than 100%, And here, this is a magical little formula here. 10 degrees Celsius per 1,000 meters. Easy to remember. It's nice and round. The normal lapse rate is 6.4 degrees per 1,000 rate. And again, this changes here. The environmental lapse rate changes from place to place. Dry adiabatic, 10 degrees per 1,000 meters. Now, when air has a lot, or at least an adequate amount of water vapor in it, air rises at something called the moist or sometimes wet adiabatic rate. And the average for that is about 6 degrees per 1,000 meters. So wet air cools with a rise in elevation much more slowly, by 4 degrees less per 1,000 meters than dry air. Why? Because when condensation occurs, so when that water vapor goes from vapor form to liquid water, there is a release of energy, and that release of energy heats the surrounding air. It goes from the water vapor into the air itself, which then warm the air up by a few degrees. There are several conditions that you need to understand. One is a condition of instability or instability, and that exists when the environmental lapse rate is greater than the dry adiabatic rate. So here, if the environmental lapse rate is 12 degrees and the dry adiabatic rate is only 10 degrees, then you have what's called unstable air. All of this air is going to lift. There will be condensation, cloud formation, and even possible rain in these conditions. Sometimes air is conditionally unstable, and that's when the environmental lapse rate is between wet adiabatic rate or the moist adiabatic rate and the dry adiabatic rate. And so in this scenario presented in this graphic, the environmental lapse rate is 7 degrees, which is greater than the 6 degrees per 1,000 meter, but still less than the 10 degrees per 1,000 meter of the dry adiabatic rate. So what happens is that the parcel of air resist upward movement and may, if it becomes unstable, if it's saturated. Stable air is when the environmental lapse rate is less than both the moist adiabatic rate and the dry adiabatic rate. And what happens is that the air basically has a tendency not to move up. If it doesn't move up, it doesn't cool. If it doesn't cool, there's no condensation, and you get fair weather, dry weather. So there is unstable conditions is when the environmental lapse rate is greater than 10 degrees, and air is considered stable when the environmental lapse rate falls below 6 degrees per 1,000 meters.